Welcome back, guys. In this section, we are going to look at something you will use in almost every Python program, which is numeric expression. These are the calculations you write using numbers, variables, and arithmetic operators such as plus sign, um, subtraction, multiplication, and division. Whether you are building a budget app or analyzing data, understanding how numeric expressions work and how Python evaluates them is very essential. So we will explore how Python handles operations between integers and floats, why spacing makes your code more readable, and how operator precedence affects your result. I will also show you how to override that order using parentheses and avoid common mistakes beginners make. And let's jump into the key concept that will make your math in Python both accurate and predictable. Numeric expressions consist of two or more operands that are operated upon by arithmetic operators, which means numeric expressions consist of two or more numbers or variables combined with an arithmetic operator. Then the operands in an expression can either be numeric variables or literals. And what do we mean by this? Numeric expression can either be numeric literals, which means when you write plain numbers, like when you carry out your operation with plain numbers 1, 5, just plain. But when you have your data saved in the variables, then it becomes numeric variables. And there are a couple of few important points that I want us to take note when we are dealing with numeric expression. Number one is that when you say, for instance, you want to carry out a mathematical operation between two variables, numeric variables, say number 1, number 10, and one important thing that you need to note is that when you carry out an operation between two numeric variables, you don't necessarily have to code spaces before or after the arithmetic operation. And what does that mean? Say, for instance, you want to carry out a multiplication between number 1 and number 2, something like this. Look at this. You don't necessarily have to space them, but if you space them, that makes your computation more readable, like this. Look at this. If you have it like this, when you have this, you don't necessarily have to have spaces before and after the operator. But if you have it, it's going to make your code more readable. And most importantly, you will still get the same result. And we're going to print out this, but I want you to note one thing. In this exercise, we're going to be, using another way of printing instead of using the conventional ways of printing that we've been, using since we started this class. And I'm going to show you that in a minute. The conventional way that we've been using is this, that we just print out our result right away. But today we're going to try using another way of printing, which is one of the few things that we're going to look at when we get to under print function. We're going to be talking about that in the next couple of videos. And when we get to strings, we're going to talk about strings in details, how to work with strings. So if we try to print out this result, you will notice that we're going to get the same thing. Whether you apply spaces between before or after, you're still going to get the same result. So let's print this and see what we're going to get. So if you look at this now, we carry out an operation. The first one, number 1 times number 2, it gives us 50. Here I meant to type number 1 times number 2. So let's rerun this one more time. So we got 50. So this is just to, get our result more, format it in a more better way and a more presentable way. That's why we are trying to use it. Otherwise, we could have just printed out the result like this. This is what we are used to, but in the future, we're going to be using something like this. This is just an introduction to what we're going to be doing at a later time. Then another important information that I want us to also look at is that uh, in an expression where you have a mixture of integers and float, the result will automatically convert into a float. Whenever you have a mixture of the two, that's what is going to happen. So let's see and let's demonstrate. Let's change one of these to a floating point number. So number 1 here, let's change it to 5.0 and let's reprint our result and see if that is actually true. If you look at it, our result came back as 50.0, which means in an expression where you have mixture of integers with float or float with any other numeric data type, once you have the mixture, the outcome result will be float. Okay. Then another important information that I want us to notice that when an expression includes 2 or more operators, the order of precedence determine which operation are applied first. And what do we mean by that? You note that in mathematics, when we have some simple mathematical expression where we have more than one where we have more than one numeric operators in an expression, then we tend to use BODMAS to know which operation needs to be performed first, where B represent the bracket, which is the parenthesis, O represent the exponential, D represent division, multiplication, addition, subtraction. So let's see an example of that for a try. If you look at this, let's use this as an example. Trial 1 and trial 2. According to this expression, BODMAS, multiplication comes before addition. So ideally, Python will first evaluate multiplication before addition. So 4 times 5 will be 20, 20, and 20 plus 3 will be 23. But if we want to override the precedence, then we need to use parentheses. So here now we use parentheses. So Python will calculate 3 plus 4 first, which is 7, and 7 times 5 will give us 35. Let's print that out and see how that works. Look at this, and let's run the result and see what is name error. Where is that? Okay, this is supposed to be 2. Sorry about that. Let's rerun again. Okay, so if you look at this now, we mentioned 2 things. We said number 1, when you have mixture of floating numbers and when you have mixture of a floating number and integers, the outcome in an operation, the outcome result will always be float, and that's the first one. And the next one is that when you have multiple arithmetic operator in an expression, then um, then we use this expression in mathematics to determine which operation we're supposed to carry out first. So the same thing is applicable in Python. So ideally, multiplication comes before addition. So this is supposed to be 4 times 5, 20 plus 3, 23. But if we want to override this, then we have to use parentheses because bracket comes first in this expression, and that's why. So in order to see that properly, I'm going to remove this. So I'm going to remove and reprint. So you can see that the trial 1 is 23 and trial 2 was 25. I hope we understand that. Then another important thing that which I would like us to look at is to try and understand this Python arithmetic operator. We are familiar with plus, minus, multiplication, division. We are familiar with all these. The first four, we are familiar with them. These last three, I'm going to pay more emphasis on this one, which is normal division. This is integer division, or you call it floor division, modulo or remainder, and this is exponential. So I'm going to clean this off so that we can see what we are doing next. So in Python, if you want to do raised to power something, say 3 raised to power 2, in Excel we're going to write it like this. You say 3 raised to power 2, but in Python it's going to be 4, then 2 multiplication sign, then raised to power. So that represents raised to power. When you want to write something an exponential, that's what you use. So let's say result is equals to 4 raised to power 2, and this is a sign. This is how to write raised to power 2. If you print it, we're supposed to get 16. Oh, sorry about that. We're supposed to print result. Print result. Just going to print directly, and let's see what that's going to be. So the result is going to be 16. So this is how to write raised to power in Python. Hopefully, I hope that we understand that. So next, let's try and practice some questions. Especially, I'm going to lay more emphasis on normal division, floor division, and modulus, because we are already familiar with plus, minus, we all know that. So I want us to try this. So in this case, instead of using 10 and 3, instead write equal to calculate 10 divided by 3, instead of using 10 and 3, I'm going to change that and make it 25 and 4. So it's going to look like this, something like this. So this is supposed to be normal division. So in Python, this is how you do normal division. 25 divided by 4, this divided by 4. So we are using this. This is normal division, 25 divided by 4, and floor division, which is integer division. This is just going to be 2 normal division sign, and the modulus, which is the same thing as remainder, is this. These are different kind of division that you can perform in Python, and you're going to get different results if we print them out. So, and how does that work? Normal division will give you the entire result, which is 25 divided by 4 should give us 6.25, and this one, this is supposed to give us 6.25 if we print it out. So then if you look at this one, the floor division will always give us the nearest whole number, and the nearest whole number is going to be 6. The nearest whole number here is going to be 6. Why? This one, the modulo, that's going to give us remainder. So when you divide 25 divided by 4, when we divide 25 divided by 4, the remainder is going to be 1, because 6 times 4 is 24. So remainder 1. So this is supposed to be remain. This is what we're supposed to get for this one. I'm just using this to, actually explain the concept. Then let's print it. Let's print them all out to see. Sorry about that. Let's print everything all out so that we can see. Let's see how it look like if we print it out. So remember that in this class, in this current class, we introduce another way of printing, which is using this. We're going to be learning about this in the next couple of videos, but it's a good way to, start learning about what you're going to do next. So let's print out the result. So when we print out the result, you see that normal division gives 6.25. Floor division actually gives to nearest whole number, which is 6. And the last one, which is modulo, modulo always return remainder, and this gives 1. So, and if you look at the question here, another question here says convert 5.67 to an integer. How do you do that? I would say we already talked about this in our previous video. That I would like to show us here is to see what is the application of all this division, because you might be looking, why are we doing all this? Let's look at the application. Let's look at this question. It said, write a program that I extract the last digit of any number, say number equals to 427. So number, we assign 427 to a number, and we want to extract the last digit. So in order for us to extract the last digit, since we are only looking for a remainder, let's divide it by 10. But in this case, we are looking for remainder. We're going to use modulo, which is the remainder divided by 10. So when you use 10 modulo by 10, it's a print number, and let's see what the outcome is going to be. So if we print number, we're going to get 7, and this is the application right here. So I want you to try this. Extract the area code, extract street number, extract housing number, and I want you to practice this. The moment, if you can do all these questions, if you can attempt this question on your own, it means you already understand the concept. And if you have any question, you can leave me a question in the comment. I'll get back to you as soon as possible, and I will see you in the next video. Thank you.